Hello everyone, welcome to yet another video on machine learning basic series. In today's video, we are going to look at how to measure the accuracy in a classification problem. We already saw, right, in regression, we use three different types of metrics. Regression and classification are the two major types of machine learning algorithms, right? We use R, we use R square, and we use RMSE, right? In classification, which is about classifying your data set as yes, no, good, bad, we use what is known as a confusion matrix, okay? And then we will arrive at the accuracy. So what is this confusion matrix? Let us create a simple 2 by 2 matrix. Okay, let's say this is yes and no, and this is what I am predicting. Okay, and this is my yes no, which is nothing but my actual. So if I predicted yes and it turned out to be yes, it is a case of true positive. I predicted no and it turned out to be no, it is a case of true negative, right? Is this clear? I predicted yes, turned out to be yes, true positive. I predicted no and it turned out to be no, true negative. What is this? This is a case of false negative, right? And this is a case of false positive, right? Prediction is yes, but actual is no. Falsely positive. Prediction is no, but actually yes, it is a false negative. Let's take the case of the COVID related infection, right? You go and take a test, right? The test says you will have COVID and you end up having COVID. True positive. The test says that you will not have COVID and you don't end up having COVID. True negative, right? Now come to false positive and false negative. Let's look at false positive, right? The test says that you have COVID, but actually you are not having COVID, right? What is that? False positive. The test is falsely telling you that you have COVID, right? Come to false negative. You are having COVID, but the test is saying that you are not having COVID. That means it is false negative. The test is falsely telling that you are not suffering from COVID, right? Do you understand true positive, true negative, false positive, false negative, right? I took the COVID example because we are just coming out of the COVID pandemic to some extent, right? So we all can relate to this example better. You can use that for a disease prediction, like heart disease prediction. You can use that to predict whether a product will be successful or not, right? You can use that to evaluate whether a customer will actually leave a service provider or not, what is called as churn prediction, right? So do you understand the concept of true positive, true negative, false positive, and false negative? So how will I measure accuracy? Accuracy is true positive plus true negative divided by all the four scenarios plus false negative, right? So this will be a ratio. I can multiply it by 100, and express it in percentage terms also. So this ratio alone, right? This ratio is a value between your 0 and 1, right? So if the value is closer to 1, it means the accuracy is low. Accuracy is high. If it is closer to 0, it means the accuracy is low, right? In addition to this, in addition to accuracy, I can also assess how good the test or how good is the model is in assessing the negativity, right? That is the no factor. How good is the model in correctly predicting the positivity, right? That also I can do. True positive divided by true positive plus false positive. That is how good the model is in assessing the positivity. Similarly, I can also assess how good the model is in assessing the negative aspects, the negativity, right? That is false negative divided by true negative plus false negative. So I can look at accuracy, I can look at the sensitivity for positivity, sensitivity for negativity, right? I can use those kind of measures as well. I can play around with this table, play around with information in this table and arrive at different sets of metrics depending on the type of model I am working on, right? So please keep this in mind. Okay. So accuracy tells me how good the model is fitting, right? How good the model is, how reliable the model is, right? Whether the model is reliable to assess positivity, whether the model is reliable to assess negativity, I can look at additional metrics. Please keep that in mind. This tells overall, how good is the accuracy. I can go to granular levels of accuracy, accuracy for positivity, accuracy for negativity, so on and so forth. Are you getting this? We also use another metric known as area under the curve, right? That is also an expression of accuracy. Okay, how good the model is able to accurately predict positivity, accurately predict negativity, right? The overlap between positivity and negativity, how low is that? Those things are assessed using the measure known as area under the curve, right? But as part of the basic series, this is what I wanted to cover, right? Accuracy in classification itself can be a detailed session, right? I will cover that possibly in another video. But as part of the basic series, understand this, right? You need to understand the confusion matrix. This is very, very important, right? So the way we assess accuracy in regression is very different. The way we assess accuracy in classification is quite different, right? So primary tool that we use to assess accuracy in classification is the confusion matrix. Everything else follows from that, right?